Hello, everyone, and welcome to the next installment of the 30-minute workout webinar series. My name is Angel Espinoza, and I am an Autodesk infrastructure technical specialist. Today, I'm joined by my colleague, Jerry Bartles. Alan Gilbert and Jeff Bartles, names that are probably familiar to you, could not attend today. In today's session, we will look at creating a surface from a point cloud in InfraWorks. For those of you that are not familiar with the concept of this 30-minute webinar series, we attempt to address capabilities beyond the typical need-to-know training. Because it's not possible to cover everything in training, this webinar series intends to show tips, tricks, lesser-known tools, and features that some people never learn about or would learn after a lot of use. This way, you can make the most of your Autodesk investment. As far as ground rules, examples will be abstract in nature to focus on the functionality. Once you learn how the capability works, of course, you can apply that in many other situations. We will try to start on time and end on time. We truly value your valuable presence. If for some reason you are unable to watch the series live, know that all sessions are recorded, and anyone that registers for a session can view the recording at their convenience. This may also minimize your need to take notes. If you have any questions during the session, please type those in the question and answer pane. Jerry will be addressing as many as possible during the session. I may address questions that are unanswered at the end. If we are unable to address all of the questions during the session, someone will get back to you with an answer. If you want to have a one-on-one follow-up call with one of us about a topic that was covered in a session, please type that in the chat pane. We always look forward to chatting with everyone. Now for today's agenda. We will start by briefly talking about how do people get point clouds? And that brings up a briefer discussion about just different types of point clouds. We will then talk about Autodesk Recap Pro and Recap Photo, which most of you likely already own as part of your AEC collection, and how they contribute to the workflow. Then for the main focus, we will use Autodesk InfraWorks to see what it can do. Lastly, we will end the process with Autodesk Civil 3D. Keeping with tradition, this session will be a PowerPoint-free zone. I will be live in the products until I recap at the end of the session. Let's begin. I'm going to start by toggling over to Autodesk Recap. And I will have 4 examples of different types of point clouds. Beginning with this first one here, you may be able to make out that says static site or scan. So I'm going to go ahead and do that. Now notice this says sync project files. I am storing everything that I'm utilizing in Autodesk BIM 360. So basically in the cloud. So this is just double checking to make sure that my version that is local is the same as the version in the cloud. Now this particular static scan is very common amongst the types of scans, types of point clouds that people will receive from surveyors. Basically, they'll take a stationary LiDAR scanner and set it up somewhere. So if I zoom in on this, we will be able to make out the different setup points. You can see them as a kind of a spray of points from a certain location. And this is where that particular scanner was positioned at that moment. You can even see the case that it was in and the shadow that it cast. So if I come right around here, that's probably around the position of the scanner itself to have cast that particular shadow. Now, then they moved down the highway and did another setup point there and there and there. When all is said and done, they used 12 different setup points to create this particular point cloud or LiDAR scan. So this, again, is an example of static point clouds. Now, coming back to my dashboard here, my main screen, I'll next bring up another example. I'm not going to save that first one, synchronize this one. This one is called a mobile scan. So typical, again, of a type of scan that some people may see. I see a dimension here. I'm going to go ahead and get rid of that. Let's remove that from the scene. And what we're seeing then is what was gathered from a vehicle that was driving down this lane of the road. Now, how do I know it was driving down this lane of the road? Well, if I come down to this area and I turn this around a little bit, you can even see, let's say this guardrail here is casting a shadow behind it. So right around this elevation, and as I look around the scene, you will see things like the near side of cars across the highway here and here. Again, further evidence that the car was traveling on this side. Now, this can be very useful. It gathers a lot of information quickly versus the other one, which requires the surveyors to set up and reset up continuously down the road. This one can gather a lot more information, but as we see here, it can have the tendency to create shadows. So unless they're coming back in a different lane or coming back in the opposite direction, that's when we start to eliminate some of the shadows in those scenarios. Now, coming back to the main screen here, I'm going to use and bring up another example. This one I titled FODAR from drone. And what does that mean? Don't save that one, synchronize this one. And FODAR, which stands for photogrammetric detecting and ranging. So this is a point cloud created from a series of drone pictures. Now, anybody can do this because with Recap, which I'm currently in, the product right up here at the top, there is a companion product that also loads, and it is called Recap Photo. And here in Recap Photo, you can see exactly the part of the resulting part of the process where if I remove the textures that was draped on this, this is a mesh. So this is another potential output from a collection of images, which I'll show in just a moment. But you can see that this mesh and this point cloud here are very much the same. Now, how does that create it? Coming back to Recap Photo, I'll come to the dashboard, I'll create a new aerial project, and then this will allow me to browse to some images, and I'll click there. Let's go ahead and do that. There we go. And I can then load up, as in this example, I have, I think, 65 different images. I hit open, and all 65 of these images will load. Now, ultimately, you can see the total down here in the lower left-hand corner. Ultimately, I would create this, and then these images would load up into the cloud, and those two resulting items would be created, the mesh and the point cloud, if that's what I wish. There are other resulting values as well, like a ortho photo created. Basically, it's a mosaic of all of these images that are corrected into one. I'm going to cancel that project. So I'm going to go ahead and step out of, I'll leave it on the dashboard there. So that is the second, or excuse me, the third type of point cloud that one might get. Now, there is technically another related one, and this one says FODAR from manned aircraft. So it is possible for larger sites, and as a matter of fact, there's services, and I'll talk about one in just a moment, where you can grab large areas. And thanks to our partnership with Nearmap, I was able to utilize, and I'll talk more about them in just a second, I was able to utilize this particular point cloud, which is what I'm going to use inside of InfraWorks. Now, this is just a small portion. Nearmap does create large swaths, but I only wanted to focus on this particular portion. This happens to be also a project here that I can see from my home. And when I was a young man, I worked on the development of the golf course and the hill and the homes up above the golf course. So I often use this as an example. I'm very, very proud to have been involved with that particular project. So the fortunate thing about this is when we get point cloud information, it's very often, very commonly georeferenced. So that makes it really simple to utilize. So having then one of these various types, whether it's static, mobile, FODAR from drone, and FODAR from manned vehicle, absolutely possible. Now, one type of LiDAR point cloud that I didn't mention was aerial LiDAR. I didn't have an example of that, but that would be mounting a LiDAR detector on an aircraft and scanning things from above. Again, both of these were generated from high resolution imagery taken from above. So now I'll go over into InfraWorks and briefly talk about how I set up the data set very quickly. For those of you that are not familiar with InfraWorks, there is this component called Model Builder. And in Model Builder, you're able to pick an area. And again, I'm in La Habra currently. So I'll zoom over to this area and we can see the golf course there and the shopping center. I'll change that to an aerial view. And it's possible to define an area to create, for InfraWorks to create a model automatically for us. Now, when we do so, all we have to do is give it a name, choose a coordinate system, hit this create model button, and it will do that in the cloud, and it will then be available for us to download. It's exactly what I did to start this process. So coming into my model here called 30-minute workout, you will see this area, and this is exactly what I got from the model builder, which is terrain from the USGS. If I change my view to a custom view that I created with includes contours at 0.5s and 0.1s, you can see I can zoom in here and then look at the various contours of this. This data, typically, if I change this to wireframe, we'll see the specific nature of the surface data that we get from Model Builder automatically. Again, I mentioned that was the USGS. And typically, we get a gridded pattern of that surface of about roughly 25 by 35 feet on the grid. You can see a seam there where it brought two tiles together of data. So again, this surface automatically generated, the Bing Maps imagery was automatically draped on it. If there are buildings on the site, they would be present if they're part of the database. So that's certainly possible as a part of just Model Builder. Now, what I then did was, again, thanks to the courtesy of Nearmap, was I created a proposal called Alternative 1, where I added in a more or higher resolution patch of surface. Now you can see this area that looks to be almost solid or perfectly dense, but in reality what that is, if I zoom in on this, it's just a significantly denser surface. You can see as I come in really close, this surface is now 1 foot by 1 foot. And in the area where some of this, we can begin to see things like these sand traps here, we're beginning to see a little bit of the relief from this higher resolution surface that wasn't present in that 25 by 35 foot gridded surface from the USGS, right? So in this area, we can start to get a little bit more accurate data from that process. Now, what I then did is I started alternative number 2, another proposal. And here what we're going to see is, again, the 25 by 35 foot grid, but additionally, I'm going to turn this on right there, there's a point cloud that I'm going to utilize for the main portion of this demonstration. So as we click on that, it takes a moment just to load. You can now see if I zoom in on, let's say, these trees, that eventually I'm getting to the point where I am seeing points, right? So that is the point cloud itself, automatically placed. One of the things I like about this process and LiDAR general and LiDAR data in general is that it automatically lands exactly where it's supposed to, because much of it is geo-referenced. So now, what is possible? And here's the main capability that we want to focus on. Up here on the Manage tab, and we look at this panel over here called Point Clouds. The middle command, or technically the second command in the pull down, which happens to be the first 3 are on the icons themselves, is called Point Cloud Terrain. If I hover on that, it says process your point cloud data to generate terrain data. So we're going to go ahead and do that. So I'll go ahead and click on that. It'll take just a moment to scan the model, and it'll determine, yes, there is in fact a point cloud here, and it sees the name of the point cloud, and will attempt as a part of the process to generate a terrain from that. So let's look at the particulars of this and understand this a little bit more in detail. So what this does is it looks at that point cloud, and there are 3 settings: one for ground, one for linear features, and one for the vertical features. There is this toggle here to fill and to override the point cloud. I'm not going to override the point cloud. Actually, I am. Sorry, I need that on. I just toggled it off. Let's toggle it back on. And what it's going to do is it's going to take that point cloud and create a new point cloud from it. And it will, in that new point cloud, be generated in one of the following ways. There's lightweight point cloud, there's key points, and all points. Now, I did this via all of these methods, and I have an Excel spreadsheet on my other screen where I saw the results and the differences. I should state that that area and the point cloud that we're looking at contains, if I remember correctly, 3.5 million points. Again, 3.5 million points for that point cloud in the background. So if all I know to do, again, coming here, hit that point cloud terrain, it looks for the point cloud. I saw the settings set to optimum, optimum, optimum. We're going to create a new point cloud there. The default is lightweight. If all I do is hit start processing, it will then begin to analyze that. Now, I've already done that, and a la Julia Childs, I'm going to go ahead and go to my next proposal, which here is called Alternative 3, Terrain 01. Now, in Terrain 01, while that's changing, I'm also going to bring up my Excel spreadsheet on my other screen. Where are you, Excel? There we are. Just to provide a little bit of the background in here, I'll drag it over so you can see some of that information. Terrain 01, I left it at optimum. The terrain resolution setting was set to 2000. I left it as lightweight. It took 2 minutes and 20 seconds to process that. The resulting surface was 1.6 by 1.6. It was 5.3 million points, which in 140 seconds, it processed 38,000 points per second to be completed. And in this model now, in this proposal, is the result. And let's look at the result. What I'm going to do is first zoom in on this, and we will see that the resulting surface and the resulting point cloud, because remember, it created a new point cloud from the original, are exactly one and the same. In my previous proposal, there were points where my point cloud was above the surface, where my point cloud was below the surface, but now they're one and the same. And if I bring up the point cloud theming, which I already have on my other screen, let's bring this over here. It is possible to create a theme, and I'll do so on the fly really quickly, for that does the classification, and it's going to be from 0 to 255, and I'll call this 30-minute for the 30-minute workout, and hit OK. And what it's going to then do is stylize all of the points in this point cloud based on the classification and how it determined those points to be. Now, you'll notice that there's a lot of swath here in the gold, and that is because it considered that ground. If I create another new one, I'll just create another new one on the fly. I already had them prepared, but it doesn't take long, so we can do this on the fly. Again, going to classification, if I just say, show me classification 2 to 2, start at 2 and end at 2, these are the points that are classified as ground, and I hit OK, then those are those points that it classified as ground. And as I zoom in on this, and those sand traps do provide really good example of where it made the surface follow the point cloud itself. So that being the primary gist of what we're doing, right? So I'm going to go back to a conceptual view where, oh, no, not conceptual view. I want 1s and 5s, 0.1s and 0.5s. And you can see the detail of that surface generated from the point cloud. Again, that entire process took 2 minutes and 20 seconds. Now, I should also state that when that happens, when it creates this, what it does, and I'm going to bring up the surface layers, drag it over here. What it did was it created this surface, and it was technically right here. And the process even tells me, it gives me a little message that says, I created a new surface. It has the following name, which is basically the name of the point cloud. It's in the uncategorized section of your surface layers, and it is currently off. So we dismiss the dialog box after that was created after the 2 minutes and 20 seconds. And then I just drop it down here to be part of the actual ground. I turn it on, hit apply or OK, whichever. It's already there. So this is the result. And that's exactly all that was necessary, is to take a surface and ultimately generated from a point cloud and have it be populated into the main portion of your InfraWorks model. Now, there's still other things we want to take a look at, which include the following. Remember that as I went to the point cloud terrain command, this was set to optimum, this was set to optimum, this was set to optimum. Well, what happens and what other options are there? There is the ability to choose less detail, which was one of my other proposals here. Then there's the ability to choose more detail, which again was another proposal. But lastly, I'm going to focus on what happens when we choose custom. This one we need to understand because there are some ramifications about this. In custom, there's primarily a few things that we want to be aware of. It says ground detail. And this value, ground detail. How much ground detail do we want? Do we want this to be smaller and have smaller ground detail or larger ground detail? The smallest I can do is 0.33, and which is technically that is a tenth, 0.33 feet, a tenth of a meter. Yeah, a tenth of a meter. And then the other thing that it does, and I want to point this out because it's rather important, is that it uses this processing window for currently set to 20 meters for how many points, how large an area is going to analyze at a time, right? So what that then does, it's doing 20 meters at a time. It's comparing 20 meters and trying to determine what is ground and what is not ground. So if I were to have had all of these, what are the trees? What are the low brush? What are the buildings even? Now, I mentioned buildings because in this example that I use, I chose it very specifically because there is this large retail store that is bigger than 20 meters. And so what we can then do is, and when it was set to 20 meters, you can see all of these gold points that it saw, because it took 20 meters at a time, 20 meters here, 20 meters there, 20 meters here. And it said, all of these are relatively flat. They must be ground. When in reality, that's the top of a flat roofed building. So what we can do is we can make this processing window bigger. Its maximum value is 328 feet, which is 100 meters, 328. If I try to type in 329, you can see it won't let me. 29,999, it won't let me. 28, it will. So again, 100 meters and a tenth of a meter at the smallest side there. So doing that, and then I want to point out, I would change this to all points. I want my resulting point cloud to have and include all of the original points. So I typically do that. And then there's this value here, fill terrain holes, right? And I want to talk about that in just a moment. So fill terrain holes is on. So here, what did I change when I went to custom? I went to 0.33. I changed that to 328. I left that. I changed this one to all points. And I made sure that fill terrain holes. Once you start processing, I ended up with this one, this last one here. And what it did was, even with the bigger processing window, it was able to determine portions of the building top that were not ground. But that building top is still so large, you can see those portions now are not highlighted. But that building top is still so large that it still found a bunch of them and said, well, they must be ground because there's, I still see them. So in much of the model, it was able to determine, yeah, perfectly what is the let's do the point cloud theming again. Let's classify, remove that, and classify everything. And you can see how it was able to determine what is ground and what are the trees, what is the low brush, what are these other items. Now, I want to do one last test with buildings that are not this large. So I then brought in a point cloud, again, courtesy of Nearmap. You can see this one here. I'm going to go to another proposal. And in this proposal, alternative 4, I just brought in a point cloud in this area, which includes this street and cul-de-sac and some homes. So to this area, alternative 4, oops, that's still the main one. Let's go to alternative, that's it, alternative 5. And then I'm going to go to alternative with the terrain already generated. So let's see what happened. Not to spoil too much, there's the result of this smaller area, and this is where those homes were. If I toggle off the stylization, you can see that there's a portion of a home here, 1, 2, 3, 4, 5, 6, 7, 8 full homes and a partial home. And if I toggle the classification back on, you can see that it did in fact identify those as vertical objects and didn't classify any portions of those as ground. So it was able to determine the street, the sidewalk areas, the golf course areas rather well, and all of the foliage around the homes, the larger trees, the smaller trees, and the homes themselves, it was able to make that determination. So this works out rather nicely. Now, one last comment about these. I'm going to go ahead and turn off the point cloud altogether, and then just lastly talk about the Turn that off. Lastly, talk about the surface. If I put this back in wireframe, you can see that it was able to fill the holes that were those houses, and that's what that setting does. It basically created a grid straight across where that house was, right? Now, fill holes does not work if the hole touches an edge. So here, I'll call this a peninsula. It extends all the way back here. No, this one, sorry. This one, it's a peninsula of trees that go all the way to the edge. So it wasn't able to use that as a fill hole, and I still have the original surface underneath there. But everywhere else where those homes are inside, like these 3 homes, it filled the hole. Now that one touched the trees to the edge. These touched the trees all over here to this edge. So it didn't fill those holes. But that's what the fill holes command. As long as it does not touch the edge, it will fill those interior holes. Now, lastly, is the discussion about Civil 3D and what happens in Civil 3D and how do I get the data there, and what are the values for that resulting information. So here I'm inside of Civil 3D and inside of InfraWorks. I need to go back there, and I'll just close it for the moment because I can't have the model open if I'm going to do the following. Now in Civil 3D, if I use the insert command, I can say open from InfraWorks model. I can then browse to the model, and there it is, 30-minute workout. It is a SQLite file, which is what I know InfraWorks is. And we'll go ahead and click on that. It'll find it, it's looking at it, it's opening it, and it did one very, very critical part of this. It understood that the coordinate system and verified that the coordinate system for the InfraWorks model and the coordinate system for Civil 3D are one and the same. So if that's possible, then I can go ahead and say open the model. Now, it is possible for me to pick a smaller portion of the model. I can refine the selection set and just bring certain components. But here, if I choose open model, it's going to find the 4 objects that were in that InfraWorks model. I believe it's 4. And, oh, I chose the smaller surface, didn't I? There we go, 4 items, finished. It took about 20 seconds to do that. And now I can grab this, right-click, place that in the object viewer, and what we're seeing then is let's go off of, we'll go to wireframe, and seeing this entire surface with the tighter surface there, that was the area around the homes, right? So you can see ultimately how that gets brought in. Took 20 seconds. So the processing, a couple minutes, the end result here, about 20 seconds. So I'm going to go ahead and close that and just mention that I had wanted to compare the optimal, everything by default with my highest setting value. And you can see everywhere I've stylized my surface style so that everywhere that the surface is within a 1/10 difference, it's see-through. And everywhere it's more than a 1/10, which is in all the wooded areas as it's trying to discover the brush, it was able to determine that there is a slight difference, right, between the 2 surfaces, but very much the same. So the vast majority of it in the flat areas here of the substation, the parking lot, the road, the cart path itself, all of that is within a 1/10, whether I left that as optimal or I changed it to the highest resolution, and only in the areas of the brush and the trees and so forth did it see any differences at all. So just to give you that sense of confidence. So to recap, for today's agenda, we covered getting point cloud data, various types of point cloud data. We saw how Recap Pro and Recap Photo can be used to import that data and turn it into an RCP file, which is what the vast majority of Autodesk products utilize, and then bring that into InfraWorks. InfraWorks was able to subdivide that point cloud to determine what is the surface. And lastly, we brought that over into Civil 3D. So with that, I'm going to ask Jerry. Jerry, were there any questions that we can address at this point?
You know, Angel, we just had one. There was a question about the spreadsheet, the Excel spreadsheet you had created, if that was created automatically.
No,
or if that was something that you would prepare.
No,
okay, that's what we had thought.
Yep.
Okay. Yeah. No, that was the one remaining one we had.
Excellent. So with that, if you would like to get a follow-up one-on-one chat about the topics, don't forget to put that in the chat window so that that can be arranged. On behalf of Jerry Bartles and Alan Gilbert and Jeff Bartles, who could not attend today, we thank you for attending. We are super appreciative of your time. We hope that you found this time valuable, and we look forward to our next time together in 2 weeks. Bye for now.